Hey guys, let's pause for a moment of science today and talk about heat. Heat is a type of energy, it is a type of thermal energy, and heat is always on the move. It moves from one location to another and is constantly on the go. Now the cool part about heat is that although we can't really see heat, we can tell where it is going to travel to every time without mistake because it's extremely predictable. It moves in a very specific pattern. And so what we're going to do is we're going to do two little activities together today to help you discover and remember how heat travels. Now when we talk about heat traveling, we use the term transfer. When heat moves from one place to another, from one location to another location, we say that that heat transferred. So now we're going to find out real quick how heat actually transfers. Does heat transfer from hot objects to cold objects, or does heat transfer from the cold objects to the hot objects? And we're going to find that out. Now, you're going to think I'm crazy, and most people do, but this is a really quick way for you to determine how heat actually transfers. So take your hands and I want you to fold them under your armpits. I know, I said put your hands under your armpits, and instantly you will begin to see that the temperature is already changing. There's definitely a difference in temperature going on under those armpits. But the question is, how does heat transfer? Does it move from hot to cold, or does it move from cold to hot? Well, my hands are now very, very warm from my armpits. So I know that the heat transferred from my hot armpits to my very cold hands. All right? Now, another way that we can better see how the heat transfers is using an ice cube. Okay, so what I have to show you now is another really cool way you can do this at home, that you can show how the heat transfers, how the thermal energy moves from one object to another. So if you take your hand and you place an ice cube in your hand, you will notice that there is an immediate change in the temperature. Now, even though I can feel my hand getting cooler because it is touching the ice cube, my hand is virtually unchanged other than the temperature. But if you can see, the actual ice cube is going through a different change. Can you see that? Do you see how the ice cube is actually melting? Well, that's how I know. See, I've even got some drips going on there. Because the ice cube is melting, that is how I know that the heat is transferring from my hand to the ice cube. Because if it was the other way around, then that means the ice cube would freeze my hand solid like the ice cube. So we know that that's not true. Because my hand is not frozen like the ice cube, and also because the ice cube is melting because it is getting warmer, then I know the heat from my hand is warming the ice cube. Now, I did tell you earlier that heat always moves, and it does. And it will move from the hotter objects to the colder objects until they reach the same temperature. Nature craves balance, and that heat will stop transferring as soon as they both reach the same temperature. So if I held this ice cube a little longer, it would melt completely down, and the energy would be the same between the liquid water that would be in my hand and my actual hand. If I held it here long enough and enough energy from my hand transferred to it, they could become the same temperature. All right, I'm a little wet, but that's okay. I do want to tell you something that I think is really cool about heat. We say hot and we say cold, and this is going to freak some of you out, but there really is no such thing as cold. I know, I'm going to say it again. We say hot and we say cold, but there's really no such thing as cold. Scientifically, cold does not exist. You either have heat or you don't have heat. A good way to explain that is a refrigerator, how a refrigerator works. All right, so I'm going to draw a refrigerator. And this is why they only let me teach art for 4 days, and that's a true story. So, no matter what your refrigerator looks like, mine looks like this, and this is the freezer part, and there's the handle, and then over here you have the refrigerator part. So this is the refrigerator part, and this is the freezer part. But no matter what yours looks like, you will have, and I'm going to pull you a little closer. There you go. You will have these little vents down at the bottom, okay? And no matter what temperature your refrigerator is, or your freezer is, or how old it is, or how new it is, it will always, 100% of the time, be very warm down here. Now the reason for that is because that is how you make a refrigerator cold. You have to remove the heat. So inside your refrigerator, the temperature is very cool. And the reason why this part down here is constantly blowing hot air is because that is where it is removing all of the heat. If you remove the heat, well, what do you have left? You have no heat. And when you have no heat, you feel cold. So that's what's going on. That's the heat and cold, the energy, the no energy. That is best explained, in my opinion, by a refrigerator. Because the only way that you get the refrigerator to work is you don't pump in cold air. It doesn't work that way. You actually have a condenser, which is true, but you have a fan that will draw the hot air out. And when you take out the hot, you have cold left. Okay, so now I want to talk to you about that energy a little bit more. When we talk about it getting hotter or colder, we've learned just now that there really is no such thing as cold. I know, sounds really weird, and you'll hear me say cold all the time because that is just an easy habit way of describing the temperature for me. But I do know that it is hot or it's not hot or it has less heat. And when we talk about energy transferring, we talk about if an object is getting hotter, we say it is gaining energy, or if an object is getting cooler, we say it is losing energy. So what I am saying is that warmer is gain, and cooler is lose. Okay, so let's go over some objects together, and you can tell me if that object is gaining energy or if it is losing energy. So if you have ever walked barefoot in the summer on the sidewalk, are your feet gaining energy or will they lose energy? Well, you have to decide. Are your feet, when you step on that summer sidewalk during the day, let's make it very clear, during the day on that summer sidewalk, are your feet getting hotter or are your feet getting colder? They are getting hotter. And so when you step barefoot during the day in the summer on the sidewalk, your feet are gaining energy. If you pick up ice in your hand, like we did a while ago, right? And the ice began to melt, well, what's happening to my hand? It's getting cooler. I can definitely feel the coldness from that ice cube, but my hand is losing energy. How do I know? Well, because it gave it away. It gave away its energy to the ice cube. So my hand felt cooler and the ice cube began to melt because the heat literally transferred from my hand to the ice cube. So my hand was losing energy, but the ice cube was getting warmer, right? Because it was melting. So the ice cube was gaining energy. Now I know that is really, really tough. When you think of ice, you think cold. But if the ice is melting, it's melting because why? Because it's getting warmer. So if the ice is getting warmer, it's actually gaining energy.